You know, a few months ago, I found myself in a situation that I never would have imagined when I became FCC chairman. I was in Dallas, Texas. I was at the helm of an excavator, a big piece of heavy machinery digging up dirt. And for those of you who want a picture that's seen in your mind, yes, I was wearing a suit. I was also wearing a pair of virtual reality goggles, and I hadn't left the FCC. And while I may have been in Washington physically, I can tell you I was at the excavation site in Dallas, 1,400 miles away. I sat in the mock-up of the excavator, and I had complete control sensitivity to the equipment 1,400 miles away. Now, granted, digging up dirt in Dallas probably isn't high on the list of transformational advancements that will define the 21st century. But I want you to think of something. Why don't you replace the heavy machinery with a scalpel so that a world-class surgeon can move from hospital to hospital without leaving her surgical suite? Or how about students sitting in a classroom taking a virtual tour inside the human body? Now, we've all heard of amazing things, stories like that in the past, but making these kinds of activities possible without a fat cable leading to the virtual reality headset could not be accomplished because of three limiting factors. One, the speed of the wireless connection. We all know the difference in performance of a direct fiber connection compared to a wireless connection. The next generation of wireless must be mobile fiber, 10 to 100 times faster than what we're used to today. Second limiting issue is responsiveness. The surgeon's scalpel needs to be immediately responsive, not a blink later. The technical folks call this latency. It currently averages about 10 milliseconds, or 1/100th of a second. Now that may sound pretty fast to you and me, but it's a snail's pace in computing. Latency needs to be less than 1 millisecond, less than 1/1000th of a second to provide for real-time interactions. And the third limiting factor is spectrum capacity. Because if you're going to have that kind of high speed and low latency, you have to have the ability for digital information to race down broad chunks of spectrum. Multiples of what we know today. So to overcome these challenges and to seize the opportunity before us, we need the next generation of wireless connectivity, a fifth generation, or 5G. And if the United States is going to continue to be a world leader in wireless, we need to speed the deployment of 5G here on our shores. The virtual reality example that I gave is but one sample of the effects of high-speed, low-latency connectivity, and why American leadership in 5G must be a national priority. That VR example that I gave you was just one example of how the driving force of the 21st century will be powerful processing centralized in the cloud and wirelessly connected to thin clients. Autonomous vehicles will be controlled in the cloud. Smart city energy grids, transportation networks, and water systems will be controlled in the cloud. Immersive education and entertainment will come from the cloud. But such futures won't come to pass unless the pathway to and from the cloud is low latency, ultra fast, and secure. Now, if we've learned anything in the generational march through wireless connectivity, it's that we have always underestimated the innovation that would result from new generations of wireless networks. The first generation wireless, 1G, was voice. In the early 1980s, McKinsey told AT&T there would be 900,000 cell phone subscribers by the turn of the century. Well, it turns out there were 109 million. They were only off by a factor of 100 or so. The second generation, 2G, allowed both talk and text. But no one understood the power of text. From shifting the way an entire group, teenagers, would communicate, to developing a developing world tool for banking the unbanked, innovators seized on the new capability of texting in unimaginable ways. The third generation, 3G, married wireless and digital networks to open the door to connecting with the other new technological development of the time, the internet, in a limited way. And today's technology, 4G, completed that digital migration, enabling higher speeds for sophisticated applications, including video. Again, greater capability in the network led to unanticipated innovation. Without 4G, there would not have been Waze, or Uber, or Snapchat, or Instagram, or the list keeps going on. But I've listed some examples earlier, a moment ago, about what 5G makes possible. But if anyone tells you that they know the details of what 5G is going to become, run the other way. Because it is the capacity to use this new capability that will determine what our future looks like. Yes, 5G will connect the Internet of Everything. If something can be connected, it will be connected in a 5G world. But with the predictions of hundreds of billions of microchips connected in products from pill bottles to plant waterers, you can be sure of only one thing. The biggest Internet of Things application has yet to be imagined. Yes, 5G will connect the unconnected and compete with the uncompetitive. Millions of Americans can't access high-speed connectivity because it's too costly to run the fiber to the home. Verizon CEO Lowell McAdam has begun speaking lately about using 5G connectivity to expand high-speed broadband service to rural areas. And fiber-fast wireless connectivity will deliver the long-sought goal of competitive high-speed internet access for consumers. But let's stop the imagining for a moment. Here's the key. The interconnected world that we live in today is the result of decisions made a decade ago. The interconnected world of the future will be the result of decisions we must make today. And that is why 5G is a national priority, and why this Thursday I am circulating to my colleagues proposed new rules that will identify and open up vast amounts of spectrum for 5G applications. We call it the Spectrum Frontiers proceeding, and we will vote on it on July 14th. Our 5G proposal excuse me, is the final piece in the spectrum trifecta of low-band, mid-band, and high-band airwaves that will open up unprecedented amounts of spectrum, speed the rollout of next-generation wireless networks, and redefine network connectivity for years to come. I'm confident that the actions will lead to a cornucopia of unanticipated, innovative uses and will generate tens of billions of dollars in economic activity. But let's revisit that spectrum strategy for a moment. Rule number one is that the technology should drive the policy rather than the policy drive the technology. And technology for 5G is not one thing, it is many things. The marriage of Moore's Law and wireless connectivity involves smart antenna systems, new, more efficient transmission formats, low-energy systems, network virtualization, and much more. And on the spectrum side, these technologies require new access to spectrum in multiple bands. The wireless future will not be a one-size-fits-all future. So our spectrum trifecta begins with low-band spectrum that is optimal for wide area coverage applications. At this very moment, we are in the midst of the world's first incentive auction to make greenfield low-band spectrum available. The broadcasters have stepped up to bring spectrum to the market. Shortly, the wireless industry will have the opportunity to fulfill their repeated requests for more spectrum with this beachfront spectrum. Mid-band spectrum is kind of the Jan Brady of the spectrum world. You know, the overlooked middle child. But its characteristics enable an order of magnitude increase in spectrum efficiency. The Commission's recent AWS 3 and new Citizens Broadband Radio Service in 3.5 gigahertz were landmarks in using new sharing tools to open up new mid-band spectrum, and we need to continue looking for other mid-band opportunities. And it's high-band spectrum that will be the focus of our actions next month. These bands, the high bands, offer huge swaths of spectrum for super-fast data rates with low latency and are now becoming unlocked because of technological advances in computing and antennas. If the Commission approves my proposal next month, the United States will be the first country in the world to open up high-band spectrum for 5G networks and applications. And that's damn important, because it means that U.S. companies will be the first out of the gate. We will be repeating the formula that made the United States the world leader in 4G. It's a simple formula. Lead the world in spectrum availability, encourage and protect innovation driving competition, and stay out of the way of technological development. Unlike some countries, we do not believe that we should spend the next couple of years studying what 5G should be or how it should operate and how to allocate spectrum based on those assumptions. Like the examples I gave earlier, the future has a way of inventing itself. Turning innovators loose is far preferable to expecting committees and regulators to define the future. We won't wait for the standards to be first developed in the sometimes arduous standard-setting process or in government-led activity. Instead, we will make ample spectrum available and then rely on a private sector-led process for producing technical standards best suited for those frequencies and use cases. Leadership in networks leads to leadership in uses, which quickly moves across borders. So a result of this national leadership is the creation of a home field advantage, similar to what we knew in 4G. But the main value of 5G will not be found in work share or intellectual property. The main value of 5G, by orders of magnitude, will be in consumption rather than production. It will be in material gains and improvements in the quality of life and economic opportunity. And I would also emphasize that the development of 5G is not anything like an international zero-sum game. Rather, it's a contest in which everyone can win. Our success and that of others redounds to the benefit, literally, of everyone in the world. We're already seeing the industry gearing up to seize this opportunity. I have seen 5G hardware and firmware. The technology is here. It is also important, however, to recognize that 5G technology will be a constant evolution. It would be a mistake to think that 5G can be frozen in a snapshot. It's more like a video with many new scenes, all building on each other. The systems and standards for 5G will be continually improving and evolving. And on the network side, Verizon and AT&T tell us they'll begin deploying 5G trials in 2017. And these efforts will, of course, help inform the standards process by putting stakes in the ground. And the first commercial deployments they're talking about are expected in 2020. This timeline requires that we act to pave the path today. With the new rules that I am proposing in our Spectrum Frontiers order, we take our most significant step yet down the path to our 5G future. The big game changer is that 5G will use much higher frequency bands than previously thought viable for mobile broadband and other applications. Such millimeter wave signals have physical properties that are both a limitation and a strength. They tend to travel best in narrow and straight lines, and they do not go through physical objects as well. This means that very narrow signals in an urban environment tend to bounce around buildings and other obstacles, making it difficult to connect to a moving point. But brilliant engineers have developed new antennas that can aim and amplify signals, coupled with sophisticated processing that allows a moving device to pick up all of the signals that are bouncing around and create one coherent connection. Now, to make this work, the 5G build-out is going to be very infrastructure intensive, requiring massive deployment of small cells. But it also opens up unprecedented opportunities for frequency reuse in denser, more localized networks. The ability to use this high-frequency spectrum opens much bigger chunks of spectrum. Current blocks of licensed low-band spectrum are usually 5 to 10 megahertz in width. With 5G, however, we're talking about blocks of spectrum that are at least 200 megahertz in width. And this will allow the networks to carry much more traffic per user. Gigabits of throughput in place of megabits of throughput. And the key point here is that by opening up these higher frequency bands, we're making available more licensed spectrum for mobile than in the cumulative history dating back to Reed Hunt that the FCC has heretofore made available. And we're not done. As part of our July 4th on opening up other high-frequency bands. And what we'll be considering on July 14th is not just licensed spectrum. Unlicensed will continue to play a critical role in future 5G networks. Our plan proposes a massive 14 gigahertz unlicensed band. Consider that, 14,000 megahertz of with the same flexible use rules that allowed unlicensed to become a breeding ground for innovation. Opening up spectrum and offering flexibility to operators and innovators is the most we can do to enable the 5G through spectrum sharing issues. Sharing is essential for the future of spectrum utilization. Many of the high-frequency bands that we will make available for 5G currently have some satellite users, as well as some Defense Department applications, or at least the possibility of future satellite and defense users. This means sharing will be required. That it would be advantageous for the satellite and mobile industries to come together to propose realistic ideas for their coexistence in the upper bands, and to do so quickly. Satellite and terrestrial stakeholders have suggested a range of sharing options, and the draft Spectrum Frontiers order seeks to provide a balanced solution that addresses the needs of both parties. I am confident that we will adopt rules that will enable satellite, terrestrial, and federal operations to coexist and thrive. To make sure that we have this connectivity with high-band spectrum will require a lot more small cells, which means a lot more antenna siting decisions by local governments. That's why it's important that the Commission has strengthened our environmental and historical preservation rules and tightened our shot clock for siting application reviews. America's local governments will play an important role in determining how we fulfill this national priority. In addition, all these small cells need to be connected, so we'll need a lot more backhaul. That's a challenge that we're going to address through our proceeding on business data services, the kind of dedicated access that wireless providers need to connect cell towers and antennas to their networks. These backhaul networks, these backhaul connections, can be as much as 30% of the cost of operating a wireless network. And with the additional sites required to support the use of millimeter wave spectrum, that percentage is likely to increase to as much as 50%. But in many areas, competition in the supply of backhaul remains limited. And that can translate into higher prices for wireless networks and then higher prices for consumers. Lack of competition doesn't just hurt the deployment of wireless networks today. It threatens as well the delay of the build-out of 5G networks, with the demand for many, many more backhaul connections to many, many more antenna. Before the end of this year, the Commission will take up a reform proposal supported by all the nation's leading wireless carriers, save one, that will encourage innovation and investment in business data services while ensuring that lack of competition in some places cannot be used to hold 5G hostage. Network, a lesson learned from our previous experiences is that it must be secure. So this is the third leg of the stool. New platforms, systems, software, and technologies will mean new vulnerabilities. Cybersecurity issues must be addressed during the design phase of the entire 5G ecosystem, including devices. This will place a premium on collaboration amongst all stakeholders. We continue to prefer an approach that emphasizes that industry develop cybersecurity standards, just as we have done in the wired networks. But security is an essential component of where we go on networks, and we will have the ability to think about it first as a forethought rather than an afterthought. So in conclusion, in the spirit of the election season, I thought I'd close these remarks by referencing a campaign speech from the 60s. Now, a lot of my friends here think I'm going to be talking about the 1860s. But actually, I'm talking about the 1960s, because on July 15, 1960, John F. Kennedy strode to the podium at the Los Angeles Coliseum to accept the Democratic nomination for president. And he famously challenged the American people to be pioneers of a new frontier. He spoke of harnessing the power of the technological revolution and exploring uncharted areas of science and space. JFK's vision charted a path that took us to the moon and laid out the foundation of the internet. This July 14th, 56 years less one day from when JFK talked about the new frontier, we will have the opportunity to take an historic step to open up yet another frontier that promises to propel our nation and the world forward. Once again, we're looking to the sky to unlock new discoveries and unleash American ingenuity. We are the pioneers of a new spectrum frontier. Working together, we can write this next chapter in the mobile revolution, a revolution that has already transformed our lives and society. Working together, we can unleash new waves of innovation and discovery that we have yet to imagine. Thank you very much.
Thank you, Mr. Chairman. I'll note that I'll use the wireless microphone. You can have the hardwired if that.
It's not fast enough, you know, this is the problem.
Tell me, for the American consumer who's not in this room right now, it may seem that 4G is just in its infancy. We've just seen television ads in the last year or so about that. So why is 5G so urgently important?
It's a great question, Tommy, and it goes back. I had one line that really deserves further explanation. All of the things that powerful computing makes possible can't be done on the chip on a handset. They have to be moved to a centralized place that we have now come to call the cloud. So that the work gets done up there in the cloud, and it is connected to the less powerful computing power in our handsets, or, as I said, our pill bottles or automatic watering systems. And that connection is what 5G is all about. It has to be fast, it has to be latency free, and it has to be secure. And if we can't move at high speeds between that power and its use, then we will not be able to bring that power into our hands and other places.
Well, that leads to the next question, which is you've talked about the cloud quite a bit here. How concerned are you about cyber terrorism, and are we doing enough to prevent it as we move forward?
So I think we have to recognize that networks have always been a pathway for attack. I don't care whether they were roads or waterways, all right? It's always been a path for attack. And so the current networks are no different, which places on those who build and operate the networks and those who oversee that activity a special responsibility. Under the leadership of Admiral Dave Simpson, we have moved forward aggressively with a program that works with those who are running networks to meet agreed to performance standards, if you will, as to how you secure those networks, and then to have the ability to check that that's happening, and the ability to, from that experience, be able to share with everybody else. We have been playing catch-up ball. The issue is, look at this, my phone is ringing. This is the power of the connected network, folks, the ever-connected network. The issue is that, that we now, with 5G, know the threat and have an opportunity to address it from the get-go.
Okay, we talked about how the United States is leading when it comes to 5G. What are other countries doing, and how do we maintain that leadership spot compared to Europe or somewhere else?
So the European Union, China, Japan, and South Korea have all signed a memorandum of understanding that they would all work together to develop 5G. The European Union has put up 700 million euros to do 5G research. As I referenced in my remarks, we think that's the wrong way to go. We think that making the spectrum available and standing out of the way of technology development is far better than, well, let's sit around and wait till we decide what it's going to do and then make the spectrum available, and let's micromanage the technology process. That's not the way that we're going to be approaching it.
Are there lessons to be learned from the rollout of 4G technology in the US and elsewhere that will apply to the start of 5G?
Sure, there are lots of them, not the least of which is the wireless network relies on base stations. They're going to have more base stations than ever before, and the wireless network relies on wired connections, which is why we're moving on this business data services proceeding to make sure that that those connections are charged for fairly and are competitive. You know, the interesting thing about moving from 3G to 4G was it was kind of like throwing a switch. And, okay, we're moving over here to new spectrum. There's a whole new set of expectations. I think 5G, as I said, is not going to be a one-size-fits-all. It's going to be multiple pieces of spectrum. It's going to be multiple technologies, and they are constantly going to be evolving. So I think that we can follow the 4G playbook in terms of how we get national leadership, and that's why it is a national priority, but that the 5G execution on that playbook becomes one of constant innovation, constant improvement, that American technology can lead the way.
As I was talking about when we started question time, Americans and consumers are just finally kind of seeing what 4G may offer. It seems like there's a lot of talk about what 5G is. Is this a branding exercise you're starting now? And do you think that we will be able to identify what 5G is to consumers?
You know, I was asked that question at an international conference in Barcelona last year. And Barcelona is the home of the Picasso Museum, and I had just been there, and I said, you know, 5G is kind of like a Picasso. Different people look at it and see different things. But the fact of the matter is that 5G is this high-speed, low-latency.
So basically, just to wrap it up, this guy wants it to happen. I wanted you guys to see it. You can go on CBS Sacramento, and they had a little gig about it too. I want to play this before we take off.
Fastest cell service around.
But tonight we call on Curtis Ming with
Get 5G, the fastest cell service around. Fastest cell service around.
But tonight we call on Curtis Ming with health concerns raised over the equipment.
Yeah, well, Sacramento is quite excited about this, pioneering the technology that'll roll out in the late summer. Now, the industry says 5G could be 100 times faster service, but
Sacramento, the first city in the country to get 5G, the fastest cell service around.
But tonight we call on Curtis Ming with health concerns raised over the equipment.
yeah, well, Sacramento is quite excited about this, pioneering the technology that'll roll out in the late summer. Now, the industry says 5G could be 100 times faster than current service, but it requires more equipment closer to you, and some don't like that.
The race to build a 5G network.
Today is a very exciting day.
The city of Sacramento fast-tracking the technology last year, partnering with Verizon, hoping to draw tech startups and innovation to the city. But 5G waves don't travel as far as current wireless frequencies. Instead of large cell phone towers spread far apart, it requires small cell sites closer together.
This will cause cancer.
Donna Barron is protesting plans to build small cells in her Maryland neighborhood. She's one of several people raising health concerns.
This stuff is untested on kids. Their safety is not certain.
These untested technologies are, at this time, not ready to be unleashed into our lives.
Research on
Well, I guess that's going to do it for now. Too many technical difficulties at the end here. So, you got the gist of it. Later on.